As you can see from the title of this video, this tutorial is about learning synthesis reactions. As we move on to this portion of the chapter, we're going to learn that there are actually 5 different types of chemical reactions that we'll focus on in inorganic chemistry, which is our class. Synthesis, decomposition, single displacement or replacement, double replacement, and combustion. Now, is this the only series of 5 that there are? It is not. There are other things called oxidation reduction reactions, there are complex ion reactions, there are organic chemistry reactions. But to start out with introductory chem, this is a nice set of different reactions that will take care of a large portion of the reactions that you would encounter, and we can break them down into individual reaction types and learn how to predict chemical reactions, because that's the idea. Right? To this point, I could send somebody back into the lab, have them mix 2 things that makes a poisonous gas, and you would be none the wiser. Once we get done with this chapter, you won't be able to do that anymore, or rather, I wouldn't be able to do that anymore, because you'll be able to predict what the products of a reaction are before it happens and assess safety before we go ahead and do it. So the first type of reaction we want to look at is a synthesis reaction. Each type of reaction has its own characteristic properties. And the characteristic of a synthesis reaction is that most often is an element plus an element. And when those 2 things come together, they make the most logical compound. So if you see on the left side of an arrow an element plus an element, you are going to say that's a synthesis reaction, and you're going to try to predict the most logical product you can think of. There are synthesis reactions, of compounds, but that starts to get a little bit more complicated, so we save that for the most part for AP Chem. So let's take a look at an example. For instance, if I were to look at a reaction and see that I'm reacting magnesium plus chlorine, what I would do is say magnesium's an element, chlorine's an element. That's characteristic of a synthesis reaction. So I want to produce the most logical compound. I want to merge these 2 things together, to form something that's more complex. And hopefully the most logical thing that can come to your mind is that magnesium chloride is the compound. And then you change the ending on chlorine to IDE, because compounds always end in IDE. From here out, this is just an exercise in writing and balancing chemical equations. The prediction portion is done. Right? So what we would do is go through and say, magnesium, element or compound, element. Is it a Haber-Finkel? No, which means it's just Mg. Chlorine, element or compound, it's an element. Haber-Finkel, yes, which means it's not Cl, but Cl2. Lastly, magnesium chloride, element or compound, it's a compound. Does it have prefixes? No. That means symbols and charges in cross. Mg is a +2, Cl is a -1. So when you cross and reduce, you get MgCl2. Last but not least, we need to balance this. So if we take a look, I see 1 Mg on the left, 1 Mg on the right, 2 Cl's on the left, 2 Cl's on the right. So this equation is correctly balanced just by writing the formulas. Let's take a look at another example. What if we had something like iron plus oxygen and in this example there will be something to the right of the arrow. It won't just be blank. Here is why. If we take a look, right, you would look and say, I have an element plus an element. I'm going to predict the most logical compound I can think of. So hopefully you arrive at the conclusion that you're going to get some type of iron oxide. The catch is this. Iron is a transition metal. So how do I know what charge of iron that I would be working with? And the answer is you don't. You would have to experimentally determine what the charge on iron is when you react it with the oxygen. So for the sake of doing problems, you will see either the symbol with its charge there, or it will put a Roman numeral in here to tell you, hey, this should be iron 3 oxide. Once you have that, again, it's a matter of writing and balancing. So iron, element or compound, it's an element. Is it a Hoberfinkel? No. So we're looking at just Fe. Oxygen, element or compound, it's an element. Hoberfinkel, yes, which means it's not O but O2. Iron 3 oxide, element or compound, compound. Does it have prefixes? No, which means we do symbols and charges and cross them. Iron is Fe plus 3. Oxide is O negative 2. Cross and reduce, and we get Fe2O3. Now we have to balance this guy. I see one Fe on the left, 2 on the right, 2 O's on the left, 3 on the right. So, according to our balancing rules, I always save O and H for last. So I'll balance Fe. 2 on the right. How do I get there to be 2 on the left? I put a 2 here. Now, I have 3 O's on the right, and I have 2 O's on the left. How can I get there to be 3 O's on the left? Here is an instance where you can either do the half method, because O is the last thing to be balanced, or you can find the LCF between the two of these. I like to do the LCF way, just because I think it works out a little easier sometimes. Right? So we need to find the least common factor between 2 and 3, which will be 6. So we have to get the O's on both sides to 6. That means a 3 here and a 2 here. 3 times 2 is 6 O's, 2 times 3 O's is 6 O's, but that changed Fe to 4, so we have to go back and make this a 4. So that's what we do when we're predicting. We get a compound and then we write in balance. Let's take a look at one more example like that. How about sodium plus chlorine? Right, so I look at a reaction. First thing I want to do is figure out the type of reaction. So I see an element plus an element. The only type of reaction that's an element plus an element is a synthesis. According to this, in a synthesis, I predict the most logical compound. Well, if I'm working with sodium and chlorine, hopefully the most logical compound you can come up with is sodium chloride. And then from here, it's about writing and balancing. Sodium, element or compound, it's an element. Hoberfinkel, no. So I have Na. Chlorine, element or compound, it's an element. Hoberfinkel, yes, which means it's Cl with a 2. Last but not least, sodium chloride, element or compound, it's a compound. Does it have prefixes? It does not, which means we do symbols and charges and cross them. Right? Sodium is Na, it's in group 1, so it's a +1. Chlorine is Cl, it's in group 17, so it's a -1. So you get NaCl. Lastly, we need to balance it. No O's or H's, so it doesn't matter. I see one Na and one Na, so we're balanced there. 2 Cl's and 1 Cl, so to get 2 Cl's on the right side, I put a 2. That changes Na to 2, so I have to go back and fix it by putting a 2 there. The last two examples I want to show you are an exception that I do want to cover to the synthesis rule. Right? So star this as an exception. The exception to the synthesis rule is if we see a metal oxide plus water. This is a case where it looks like it should be a different type of reaction, and later on you would see that it's a compound plus a compound, and that would make you think it's a double replacement. However, whenever you see water participating in a reaction, water tends to undergo a bunch of different exceptions, so you have to ask yourself, is it an exception to that rule? And the answer is yes. A metal oxide plus water is a special type of synthesis, right? And we only get one product, and that product is a metal hydroxide. So it's a synthesis because we take two simpler things and create something more complex. Right? But it goes against our synthesis rule of saying it's an element plus an element. So anytime you see a metal oxide plus water, you want to make a metal hydroxide. For instance, say we saw sodium oxide plus water. What you would say to yourself is, what do I have in terms of type of reaction? I have a compound plus a compound. So you would think double replacement, right? But you'll say, is this an exception because I see water? And the answer is yes. Right? The metal oxide, metal is just a generic term for something to the left of the staircase. So our metal oxide in this case is sodium oxide. So if metal oxides and water make metal hydroxides, hopefully you've gathered that the name of my metal hydroxide is going to be sodium hydroxide. And from here out, again, it's just writing and balancing. Sodium oxide, element or compound, it is a compound. Does it have prefixes? No, which means we do symbols and charges and cross them. Sodium is Na plus 1. Oxygen is O negative 2. So you cross and reduce and get Na2. Water is a common name, H2O. And sodium hydroxide, right? Element or compound, it's a compound. Prefixes, no. So we do symbols and charges. Na plus 1. Hydroxide, OH minus 1. Cross and reduce, and you get NaOH. Now we have to balance this equation. So if you take a look here, right, I have NaO and H, and you could stop and say, does it make sense to make water HOH? And if you look, I would have OH here and OH here, so we could keep it together, but I would have H on this side and no H on this side. So here's a case where we don't want to write water as HOH. So now we need to balance. I see H's and O's, so we have to save those for last. So I start with Na. 2 Na's on the left, only 1 on the right. So the first thing I do is put a 2 there to balance my NAs. Then I move on to hydrogen. 2 on the left, 2 times the 1, 2 on the right. Hydrogen is good. And then lastly, oxygen. 1, 2 on the left, 2 on the right. We are balanced. Let's take a look at one more example. This time, let's make it calcium oxide plus water. First important thing you want to do is identify reaction type. So I look, I see a compound plus a compound. That makes me think double replacement. But I see water. Right? Is it an exception to that rule? Yes, it is. A metal oxide plus water is a special type of synthesis. So we are going to form a metal hydroxide. And given what you see, the name of that will be calcium hydroxide. Now we just need to write and balance it. Okay? Calcium oxide, element or compound, it's a compound. Prefixes, no. So we take our symbols and charges and cross them. And we get CaO. Water is a common name, so H2O. Calcium hydroxide, element or compound, it's a compound. Prefixes, no, which means symbols and charges. Ca plus 2. Hydroxide is OH minus 1. Cross and reduce, you get CaOH 2. Lastly, we need to balance this thing. So I see CaO and H, CaO and H, so we're good there. Start with Ca, 1 on the left, 1 on the right. Then we go H, 2 on the left, 2 on the right. And then lastly, O, 2 on the left, 2 on the right. This is balanced the way that it is written. So this is a little bit of background on synthesis reactions. Remember, most synthesis are an element plus an element, making the most logical compound you can think of. But beware of the exception of a metal oxide plus water. And then from there out, it's just continued practice on writing and balancing the equations once you've written them out in words. If you're having any trouble, please feel free to come in for some help.